Thank you, everyone, for coming here to my session. I want to briefly introduce myself. My name is Luca Milanesio. Some of you, they know me already because I know a lot of known faces over there, lots of old friends. And my company is Gary Forge. So what do we do? So first of all, we are based in the UK. That you will be surprised was much warmer than here in California. So I was not prepared with all my sweater and so on. I got a little bit of a cold. And our main focus is open source. So what we do, we contribute to open source because our clients use open source. We do projects with clients. We get the requirements from clients. And we want to try to influence the community to make sure that the open source products, they are getting more suitable for them. But not just because of their commercial needs, just because we want to make the open source product better and more suitable for the large enterprise in general. So what do we do? So we started initially years ago with Jenkins. For the guys that have been following this conference since the beginning, how many of you followed the conference 2011, the first one? Okay, so you remember possibly my talk about Jenkins Mobile. Because I started personally with Jenkins over, there was Hudson at that time 10 years ago, and I started contributing straight away from the beginning. And then we moved to Git code review, just because Git was becoming a big thing, and our clients wanted to use it in the enterprise. It was not suitable, so we did a lot of work around that. And more recently, we started working with large clients. They are using big data. And we started tackling what are the problems of using big data in continuous delivery, but today I'm going to show something slightly different, how big data can help you out in managing your continuous delivery pipeline. So first of all, possibly during those 2 days, lots of people, they were talking to you, what is continuous delivery, what is Jenkins, what is the pipeline, and so on. I'm not going to talk about that because possibly they are, let's say, even much better prepared than me on that. And because I'm a software developer by nature, so not really a DevOps. And the focus is slightly different. I'm not going to give you a lecture on code review either, because that was maybe some talks that I did last year. Don't want to repeat myself. And if you want to know more, we have a booth over there just on the left side when you exit, if you want to know that. And I'm not going to talk about big data either, but I'm going to talk how to use big data. So I'm assuming that you know what is big data. So just to understand the current knowledge of the audience, where you're coming from, how many of you have a continuous delivery pipeline in production? Good. Do you use the pipeline plugin? Yes, no? How many of you use the pipeline plugin? Some of them. OK. It's painful, right? But it's getting better. So we started with the build flow using the Groovy scripts. And we are migrated to the pipeline. Some of them are pipelines, some of them they are not yet. How many of you are using code review inside the continuous delivery pipeline? Raise your hand. OK, so the others, so you don't do code review at all? How do you verify that the code that you're checking is working? So some of you that haven't raised your hands, some courageous guy. So do you do pull request? Let's change the question. If you don't do code review, do you do pull request? Yes, raise your hand. OK, so pull request is a kind of lightweight code review. So you're doing code review, something, let's say, I would say the beginning, the early stages. And how many of you are familiar with big data technologies? I'm talking about Hfs, Spark, and so on. See your hand? OK, some of you. OK, so you may be wondering now, so if this guy is not going to talk about continuous delivery, code review, big data, what the hell is going to spend those 45 minutes for? OK, in reality, this is case study. So I don't want to tell you, let's say, the right way to do things. I want to share with you my experience of problems that you may be facing if you're trying to do a continuous delivery pipeline in the large, and how we try to solve those problems. And for sure, many of them are the same problems that you guys are facing, and I'm sure you found solutions as well. So I want this talk to be really interactive. I'm going to show you what we did, what we were coming to, what we developed, but I want then to give the word to you. I want to be interactive, to say, if you did something different, you need to raise your hand and say, Luca, why you've done this crazy thing? We did something much simpler. And maybe all the audience said, everyone together, we can learn from each other. Because from my point of view, the focus of this summit in those 2 days is not for people, let's say, throwing at you products, solutions, and so on, but it's really for us to talk together and exchange experiences, yeah? And I want this talk to be exactly like that. Okay, so first of all, I want to show you a scenario, right? So where we were coming from, because we are dealing with large clients, doing big data projects, continuous delivery pipelines, and we found problems, right? And I will show you what we were coming from. Then learn together, because from the problems, you can always see that there is a gap. Even Jenkins, with all the plugins, all the ecosystem could be really complete, but in my experience, for whatever problem we want to solve, there are always gaps to, let's say, fill and to find solutions for. And then we experimented something different, something I haven't seen used in the industry so far. And possibly, maybe some of you have done already something in this direction. Yesterday, we were at dinner with some other Garrett contributors, and they were saying, some guys from Garmin, they were saying, yeah, we did something similar. Not really the same, but similar. So possibly you have done something similar as well. And again, I want to discuss with you. I want to start triggering discussion to understand what's going on. Okay, so first of all, that's the scenario. So we have I wasn't allowed to put, let's say, a real example from a real clients because they all have those intellectual property, NDAs, and so on. So I built together something that was quite similar to what we were doing. So we had a kind of 5 stages pipeline. So the first stage was always the code review. And we were using Garrett in some of our projects, but we were using GitHub as well in some of our projects. Because at the end of the day, there is no perfect solution. Everyone likes maybe one interface, the other, but the concept is that we were starting from a code review or a pull request lifecycle. So the people, they were getting the code locally, doing some changes, pushing for review to the Git repositories, and then Jenkins was triggering a build based on that. Of course, there could be failure, they were coming back, and if we were successful, we were going to the next step. The next step was always Dockerized. So in all our projects we were doing, we're always using Docker. So how many of you have been familiar with Docker or been using Docker in production or in the CD pipeline? So all the others, so you're not using Docker. You deploy all the time to physical environments. What do you use? Maybe, do you use something different than Docker? What do you use? VM, okay, yeah, VMware could be an alternative, yeah? We're using Docker just because our clients needed to be able to manage the configuration of the machines and the environment and the deployment in a unique thing. Typically, if you use VM, then you need to start using something different as well. For instance, maybe Puppet or Chef or Ansible and so on. If you use Docker, it's kind of easy because you can give a lot of burden to the developer as well. Then we needed to do deployments to different environments, and we were using Mesos and Marathon because we needed to be able to do all this pipeline when the code was not merged yet. So it means that once the developer triggered the code, put the code into the version control before going to the branch, so this is a pre-commit validation, we wanted to do everything, including not just the unit test, the build, but even the system test, the integration test, user acceptance test. And if that is not good, you don't even land to your target branch. And for those who are not familiar with this life cycle, there's just one slide, so I'm not going to spend so much time on that. But just to give you an idea on how it works. So basically, this type of workflow is called even the green branch workflow, because at the end of the day, allows you to work always with a green branch. You do all the validations before, you do all the type of tests before, and unless you've got a complete green state, you don't merge. It is slightly different from pull requests because all the path that you see underneath when there was a red build, a yellow build, and so on, once the change is completed, they're not visible anymore. They will be just in the code review system, but they will not be visible. Okay, so in terms of the main tools I'm going to show you here in this session, because it's going to be a live session, I'm going to use Git with Gerrit. So you could use this in something different, that is Git with GitHub, and Jenkins for continuous delivery. So I'm going to show you now the environments, because you're not going to spend 45 minutes looking at slides, likely. And so first of all, okay, they're already mirrored. Okay, so this is the code review environment. For the ones that are not familiar with Gerrit, this is not a joke. This is really the GUI. It's not very nice, but it's getting better. But it's very powerful. And how it works. So basically, whenever someone wants to make a change to a specific branch, it's pushing directly to Gerrit. And instead of creating a feature branch, a pull request, go into the GUI, click something and like that, they just need to push. And Gerrit already creates all this page that says, this is an example change. It needs some specific verification, and there is a history of people that have done different stuff. And then as well a section that basically says, that is this one. No, it doesn't work, this one. Okay. That basically says that what you need to do in order for this change to be merged. So imagine that someone is making some modification to this specific commit. So in this case, I want explicitly to break maybe this XML, to make the build fail, right? So I'm going to change this file, and I'm going to publish straight away. As you can see, I can do everything even from the GUI, because once I am authenticated, I can use Gerrit as well as an entity environment, exactly as you do with GitHub, just a little bit more powerful. And then on this side, I've got a continuous delivery pipeline. So first of all, this continuous delivery pipeline is directly linked to Gerrit. So it means whenever there is something new going on Gerrit, because people uploaded a new change or uploaded a new patch set, so a different online editing, basically the pipeline gets triggered, as you can see. And this specific triggering is not going to be a generic triggering, but it's going to be a specific triggering on those specific parameters. So if I have a look on the parameters, so this specific trigger, you see that I can see the name on what was the event. In this case, was patch set created. It means someone uploaded something. I can see what was the target branch and blah, blah, blah. One thing, so when you use Jenkins with Gerrit, the pipeline multi-branch is not needed. It's something that you need when to use, let's say, the pipeline with GitHub that is much more limited, or many other version control system, because Gerrit has the ability to use a single job to build whatever you want on different branches, on different patch sets, because manages the branches automatically. So it's more advanced from that point of view. And then you see the pipeline that continues, and at a certain point I'm expecting the pipeline, yeah, there we go, a big red. The pipeline failed. So this type of feedback is reported back to Gerrit. So you will see here that I can see an update on this change, and voila, a -1. So all automated, so Jenkins say you need to do something good in order to make this change, let's say, acceptable. And then I will go back, I will edit my file again, let's fix the problem, done, putting back my angled bracket, and publish, there we go. Okay, and then, believe me, this will trigger a new pipeline, it will be green. And it's going to be green because I tested just, let's say, 10 minutes before the talk, it was working. So trust me. I will to just speed up a little bit. Okay, so then we started applying this scenario that was well known for us. We've been using it with clients for many times in these type of projects with hundreds of components, because I don't know about you, but in the UK, everyone is going to microservices. So they don't have one project, one repo, 2, 3 repos. They've got hundreds of repos, because each microservice is small, and each microservice lives in his own repo. Are you using microservices as well? How many of you are using microservices? Some of you? It seems that they are getting really big, because microservices are directly linked to continuous delivery. Because if you want to do continuous delivery with zero downtime, you have to use small deployments, and then microservices. But that means hundreds of repositories. That means hundreds of people as well, because big projects got lots of people, in hundreds of thousands of review comments, hundreds of thousands of builds, and millions of logs. That's a big problem, yeah? Because once we started working with this workflow at these scales, we found a big problem. The Jenkins didn't work anymore. Why? Because Jenkins is good for intercepting plugin, managing builds, and so on, and is really bad in managing files and logs. So what Jenkins does is just going to create a bunch of log files all over the place. And for sure, you as, let's say, SCM and build managers, you find a solution to that. Possibly you've got something in place that goes there, take all those files and clean them up. Or maybe you define a very short policy, or you take those files you archive somewhere else, right? So that was the first problem to solve, right? The solution seemed to be simple. That is, just prune those files, put somewhere else. But there is a problem with that. When you do the continuous integration with Gary code review or another code review system in Jenkins, there is always a link between the two. So the developer will see a -1 in Gerrit, or imagine a -1, the equivalent in GitHub, right? And they will have a link to see, okay, what was the reason of this problem? But if you remove the logs, how can you know what was the reason? The developer will go there and will see, oh my gosh, the logs are gone. So why on earth this change was not good? Who knows? So I just wanted to ask one question. How many of you are facing or had been facing the same problem in the past? Of Jenkins becoming slow for a number of logs? Okay. All the others, so you don't have so many logs, or have you found a solution already from the beginning? Maybe some of you that didn't raise your hands. A volunteer, okay, over there, you wanted to say something? Okay, you store to Kibana, right? Okay, so you do a kind of backup. You put the log somewhere else. But again, the problem is that the developer will not see them anymore. I will show you why. Because coming back to this scenario, so when you do the code review and the code validation, let me just do the mirroring, otherwise you don't see it. 1 second. Just see a very nice landscape. I can leave it, but maybe. Okay, there we are. Now you see it, right? Okay, so there is a bidirectional link between the change and the build. Because whenever the developer sees that this one has failed, has a link to see why it was failing. So in this case, it's just, let's say, a set of Docker containers that are put together for the talk, so it's going to point to localhost. But imagine that here is going to point to your specific job and to your logs. The same thing happens here, because whenever you've got a specific set of logs and a failure, Jenkins shows you a hyperlink that goes to the change. So there is this bidirectional link. And if you archive the logs somewhere else, the people will not find them anymore. And if the people don't have access to the reason of a failure, they can't fix it. And if developer cannot fix problems early, it means that your continuous delivery pipeline becomes really ineffective, okay? Just to finish this one, so this was all good. Imagine at this point, you say proceed, you do this, and these automatically go and finalize your change, right? Okay, that was the first problem. So some of you have got it, some of you already didn't have it because they archived stuff up front, but at the end of the day, you need to find a solution for that. Remember that yesterday morning, there was Kazuka saying it would be nice if in the future Jenkins would be able to have a pluggable storage for logs and being able to store the logs forever. I like it. I really like it. Because that's the same approach that we took for sorting out our problems. The second one was ripple effect. So when you've got hundreds of builds, hundreds of components, yeah, and people do their homework in the individual components, and typically unit tests always work because people started using Agile, using TDD and so on, and typically people, they test locally and test their own components because that's the essence of microservices. But then what happens? Then when you do an integration between other components, even if everyone has done their homework in the right way, it's impossible to coordinate different commits across different repos with Git, right? So maybe you schedule a build, then another one doesn't work, then people start panicking and so on and say, why isn't it working anymore? So when the complexity increases, you need a kind of visibility that is not anymore the individual log. So even if you got the individual log, that microservice is not enough. You need a view of multiple repos, multiple components, multiple logs in the same place, right? Then dependencies, oh my gosh, that is really a pain in the ass because every different component needs to have a way to say that all those different things go together. And the cycle time. So all these problems all together are going to then increase your continuous delivery pipeline because maybe you started small with just a few steps in the pipeline, and then the pipeline becomes bigger because you want to make sure to resolve the problems that we talked about before, and then everything becomes slower and slower and slower. And then you are wondering why you started with the continuous delivery pipeline at all, because you say possibly before we were getting faster than that. Okay, so if you sum all of them together, then basically the build and release manager really becomes the person that is overloaded with all of these and risk really a DevOps meltdown. Sometimes you go home and say, oh my gosh, that was really a complete mess. Maybe we had 2 hours of broken builds nobody knew about, nobody exactly could realize what was the problem because everyone was looking at their individual logs, but at the end of the day, I spent half a day just in hanging around, and miracle, at the end of the day, was working. God knows why. This is what happens. This is my personal experience. And possibly some of you share the same experience, the same pain. Okay, so we had this idea. So we said, okay, we are using continuous delivery for developing big data projects. But why don't we do the other way around? Why don't we use big data techniques to help us out with all the other projects we've got using microservices? They were getting crazy because we have a big data problem. We have millions of logs, we've got hundreds of repos, we've got hundreds of thousands of builds, and this, for me, is really big. This is a problem to be addressed with another scale of tools. So we started using a little bit of tools that we knew about and others that we studied in order to resolve this problem, and we applied some basic concepts. First of all, we started collecting everything. So we started collecting the review events from Gerrit code review and from GitHub, but not for the purpose anymore to trigger any build, but just to understand what's going on. So basically, if the people that are familiar with Gerrit, basically it was just a listener to the stream events. And for the people that are familiar with GitHub, we were just getting the audit trail events from GitHub to understand what's going on. And we were getting all the events as well from all the logs from Jenkins. So instead of waiting for Jenkins to put the stuff to the file, we were intercepting the logs from the jobs themselves. If you don't know, there is a plugin in Jenkins, it's called Log Stash plugin, and it's able to capture not just the logs, but the logs plus the metadata associated with it. And we are going to see that together. And that was really, really cool, because instead of going then around all different nodes, all different slaves, all different machines, on different systems, we could have at least everything in a single place. In order to do that, we used a product that is called Apache Flume. It's an open source product. We didn't use Logstash just because it's not advanced enough for our purpose. So Flume has been there for years, is rock solid, and allows basically to get information from many different places, organize in a set of reverse sort data, and then put them all together wherever you want. And then we've chosen to put the stuff in 2 places. So we needed basically exactly similar to most of the people do a kind of live stream of events. So we put everything to Kibana, and this is what most of the people do. But the problem of putting the raw events like this in Kibana is that it's really just putting a lot of water into the ocean, and then try to find a single drop of water into the ocean. It's problematic. So we took just the real-time events into Kibana, and all the rest of it we went into HDFS. How many of you knows what is HDFS? HDFS? I will just spend a word on HDFS. So HDFS is a distributed file system. So it means that allows to define a logical file system that can spread across multiple machines. And why is really cool? Because first of all, it's unlimited. So it means allows you guys to not go and buy all the time expensive hardware with an expensive SAN and spend you a lot of money with that, but reusing a scalable system to add storage just by adding machines, and is managing automatically replication and consistency of that data. Just to give you one noticeable example of HDFS, Amazon S3. When you buy a storage from Amazon in S3, the only thing that Amazon does is just have an HDFS that is open source and is given to you, and it's just invoicing you. But if you want, you can do it yourself. So with a large media client we had in the UK, we were using HDFS to store about 50 petabytes of data, right? And it wasn't expensive at all, I assure. In the overall pipeline, I'm talking about something different. Everybody talking about continuous delivery pipeline. I'm talking about an analytics pipeline. We started to create a pipeline, not anymore to build code, but to vehicle all this data to us in order to understand what's going on. And that was the flow. So we were getting all the logs from Gerrit code review. We were getting through the stream events, and through the metrics, we were getting all the logs in real time from all the Jenkins jobs, and we were putting all this stuff into Flume. Then in Flume, basically, it's really a configuration-based system. So you say, OK, this data goes here, this data goes there, and we were storing the data. We decided to put in two different, let's say, recipients, two different buckets. The first one was going straight to Elasticsearch with some initial Kibana stuff, and the second was going to this long-term storage. And this is similar to the solution that you were mentioning, right? So you're doing something straight, taking from Jenkins, going directly to the storage. What's the value to do in this way? Because you may be wondering now, Luca, why on earth you're doing all this complication to do this? There is one thing. When you do this in this way, so when you get the logs and process them in this way, first of all, what you get is an analysis of the log and representation of the log with a format that is called Avro. This format that is called Avro is very optimized because it allows you to define already the metadata with the logs, because the logs are changing. If you want to store them forever, potentially, or at least for years, you need to remember what logs were meaning. So we need to understand that this log has some fields, the other had others. And based on HDFS, we did something really cool. We started developing Spark jobs, and we are going to see that today, in order to use those files as they were logical relational databases. And this is one magic of Spark. It's called Spark SQL. So you can get a bunch of files, maybe even millions of files, and you say, OK, those fields represent this logical entity. Now fetch them together, correlate them together, and store wherever you want. And you can do it just if you have data in HDFS. So if you guys put stuff on Elasticsearch, it's too late. Elasticsearch is not designed to be performant in that case. Just to give you some examples, some of our colleagues, they said, look, this is crazy. We'll store everything to Elasticsearch. We'll do the searches there. In order to look for something, their jobs, they were taking about 15 hours to give the results. Whilst in Spark, with HDFS, was taking maybe just 30 seconds to 1 minute. That is something you may be waiting for, right? 1 minute, I could wait for a solution in 1 minute. 15 hours, it's better if I did my log myself, right? And the data that we are collecting was represented basically through 3 different dimensions. When you talk about analytics, you need to talk about dimensions. The first one was understanding what's going on the project. So what's going on my builds? Is the build failing? No, and so on. The second was on people, because if something is failing, imagine you're a build manager. If something is failing, you need a number to call, right? You need to understand who is going on that is going to mess up my builds. And the last one is something that you probably do as well already now. Because I think I saw a little bit of the previous presentation. We were talking about system metrics on Jenkins. So this is something that possibly you already do. But the value of doing this way, that you can even correlate system metrics to what's going on. And the second dimension was the tools dimension. So when something goes wrong, imagine a system level, you could even use this type of techniques just to understand what's going on Jenkins or what's going on Gerrit. Or if you don't use Gerrit, if you use pull request, what's going on GitHub and Bitbucket, or whatever you've got, as long as it is a code review system. So I prepared a small scenario of this specific implementation we did. I'm going to show that today now. So you have seen that before I was triggering a specific build, a continuous delivery pipeline. And D was giving a feedback to the code review, and I obtained, hopefully, a green execution. So behind the scenes, I always had active this stuff. This is the RabbitMQ console. So whatever I've done has generated events on Gerrit's events queue and Jenkins job queue. And we have applied this one even to a big continuous integration pipeline that we are doing for the Gerrit code review projects. So we started using these techniques even when we built Gerrit itself. As a company, we decided to give this service to the open source community, and whatever happens here, that is, this is the build system of Gerrit, is going to put data there as well. And whatever was produced, they've been generated, as I said before, first in Kibana. So here, I've got configured basically 2 indexes. The first one is the Jenkins store, that one. And that index actually is the first row. So the data is going straight to Kibana. That is possibly something that you do today as well. So at the moment, there is nothing because just the interval was wrong. Let me just open another one. One second. Yeah, unfortunately, the network here is always slow. Maybe in the meantime, while the other is rendering, I will show you this one, Spark. And on Kibana, we could then analyze 2 things. The first one was the raw events from Jenkins. So if we wanted just to get the raw logs from Jenkins, we could do it because we were pushing all the stuff there. But ElasticSearch and Kibana, they are doing a much better job in managing those logs. Typically, it's still, let's say, not good enough for years of data, but it's definitely good enough for, let's say, days or weeks of data. So by pushing the Jenkins logs directly there and connecting them to Kibana, we could see at least and give to the developer an immediate view of the log of the build. OK, there we go. This one as well. So for instance, those are all the things that I've done now during the talk. I started the talk at 11:30. As you can see, there were many events flowing. And if you see at that, so this is much more than just looking at the logs in Jenkins, because you've got a lot of useful information for each line of the log. So something that is really important, for instance, is the parameters of the log itself. So whenever if you archive just the Jenkins log, the problem is you don't know exactly all the metadata that Jenkins itself stores into the job that you're going to remove. For instance, you've got all the information about the environment variables. You've got all the information about Gerrit as well. So if you look down here, you can see the, there we go. Sorry, not this one. I took the wrong one. So this is just the Jenkins master. Sorry, this is the Gerrit one. Maybe it was in around. But you can see all the information about what was the change ID and so on, the RESTback, and the change number. But when you correlate them together, you get something even better. Because if you see, for instance, in the screen, you see that I've got some events, and those are log extracted from a previous talk that I did exactly similar to this in Poland in June. So you can see that I can visualize the same view, the events from Gerrit. For instance, I see the change merge, comment added. Those are coming from the stream events. And what was the previous operation done on Jenkins before because of that. And the value of getting aggregated data in Kibana then is very, very simple to create dashboards. So why dashboards are useful? So first of all, whenever your manager is coming to you and start asking, oh my gosh, why do we need more hardware? Oh my gosh, why the builds are always red? So allows you to give quick answers to your managers, but even to yourself, in order to understand what's going on, and maybe point it to the right people. But secondly, and more importantly, allows you to go back to those 3 dimensions, and I'm going back now to the slides. There we go. and start understanding what's going on. So just to give you some example of the application of those 3 dimensions to different examples of use cases. For instance, in open source projects, it's very important to understand, let's say, who is the right people to use as reviewer. But this is a problem that you got as well as company, right? Whenever someone is changing one component, one thing is the official person that is in charge of that component. But something that is even more important is who is the guy that has more experience on that component. And sometimes the Git log is not enough, because you may have a lot of experience because you did a lot of positive reviews, so you know the code inside out. And maybe you're not even the author of the commits. So the first dimension, people, is crucial to understand exactly how you manage your project. The second, project commit, is even more important to understand how you need to organize your storage. Maybe you've got small repository, big projects, small projects. Understanding how to organize, let's say, the topology of your system depends on that data. If you don't harvest that data, if you don't graph that data, if you don't understand that data, how can you make wise decision? If you make a decision based on just the hunch, right, or your kind of crystal ball, it's very likely that you make wrong decisions. And when the system will go down, it's too late. And the last one is system metrics. So get your system metrics, getting the system metrics back into this bucket of information and use it is very important, because you will correlate the fact, for instance, that the system is really used and the CPU goes too crazy, and say, maybe it was because that guy pushed that stuff. Maybe yes. And you can correlate that data and understand exactly the cause effect of what's going on in your system. And that's, again, crucial to avoid what? The mental and physical meltdown when really shit happens, right? And this is important. You need to act first. You need to gather the data first, because when it happens, it's too late. Okay, future direction. So we achieved something, but we think there is much more to do. And I want now to start triggering some discussion with you. So first of all, we said, okay, we need to collect more data. At the moment, we use Java Melody to collect JVM statistics, but we want to get those statistics outside Java Melody, putting those into the picture as well. So not just the system metrics or Jenkins or Correlate, but even the JVM at low level. Then we want those statistics, the graph, to be real time. And we want to correlate events even after you go to production. Because even if your continuous delivery pipeline was good, maybe you want to see what's going on in production after a deployment. And maybe you can correlate a cause effect on that as well. We want to improve the feedback to code review and even to start applying the same system to the production data, right? And to see what's going on. And what do you think? That's the most important thing, right? Now the word up to you. Do you think that what we did makes sense? Did you do something different? Do you have different problems? The word to you. We've got about 5 to 10 minutes for questions. Okay, so let me just repeat the question. So the question was, commercial products such as Splunk or open source products such as Logstash and ElasticSearch, they could do exactly the same thing without all these kind of infrastructure put together. So what is the added value of putting this infrastructure? So the added value is the post-processing. So if you just limit yourself to get the data and push it somewhere, in terms of the post-processing, you will be always limited to the type of data extraction you've done at the source. If you didn't do any previous data extraction, when you want to do data analysis, it really becomes impossible. Just to give you some basic examples. Imagine that you said, I'm going to go to the machines, get the logs, and put it to Splunk. That's fine, but when you have the logs, each individual line becomes a different record. But you know better than me that sometimes the stack traces are more than one line. And then if you consider them as just single files, that to understand that all those lines that were the same concept, it was a stack trace, just making an example, becomes really tough, if not impossible. And another thing is something I mentioned before. So if you start getting the semantics of the data at the source and organizing them as Avro records, you can associate early on to metadata. And then correlate them becomes very simple. When I say that maybe with Splunk or just pure ElasticSearch becomes difficult, I'm not talking about just the difficulty of execution, but even the time. That was the example. The guys that tried to do an ElasticSearch straight away, they managed to get the same result, the same answers, in 15 hours. And we did it in 30 seconds. So that's the main reason. So the need for efficiency, simplicity, and even compression. Because if you get the semantics of the data at the source and you store in Avro, Avro is binary. So they were using something like 10 or 100 times the disk space that we were using. And if you have less disk space used, less data to analyze, of course it's much faster because you're going to use less bandwidth, right? Okay, so just to repeat, this is really a sharing of experience. Thank you very much for your experience. So basically what it's saying is that they don't do this type of analysis because they need this type of analysis just on production logs. But when the stuff goes to production, basically the only thing that they care about is the latest version, right? So the latest successful or failed build. And that's why they had this problem in production they didn't have in the continuous delivery pipeline. But to be honest with you, so you could use these techniques even in production alone. So when I was going to all the different dimensions, and I will go back, actually there is a fourth dimension, that is the production logs, the one that you guys are using. And there is absolute value even in applying these techniques to some of those. You don't have to apply to all of them. Because maybe you don't need for people, you don't need for projects, you need system metrics, but you need for production. But there are different realities. So for instance, we are dealing a lot with the financial clients, with banking clients. And for them, there is an absolute maximum requirement of what is called the compliance and traceability. It means that whenever something happened, even in the past, they need to demonstrate exactly who did what was the build, exactly all the components that were involved, what were the changes, who were the reviewers, and so on. In that case, they definitely need this type of feature. But I'm with you. So if you do, let's say, just the latest one, it could be that this could be important maybe just in the last week or something like that. Even though if you start using microservices, I bet you will not be able to keep a week of logs on Jenkins. Not even, let's say, a few hours. Just to give you an example, Gerrit, this is just a, let's say, I would say medium open source project. We started by saying we keep a week of logs, so just 1 day of logs. We couldn't do it. Because at the end of the day, we're going to the GUI, it was not going anywhere. The machine, they were so powerful. Because even when you start increasing the size of your project and you go to microservices, even just a few hours could be a problem. Again, if Jenkins will become much better in the future, plug in different storage, it will mean we'll start using this technique inside out in Jenkins. So I'm expecting Jenkins to see maybe the ability to store logs in S3 out of the box. And then it means that some of the parts, the Jenkins part, will be already sorted out. But the good news is that from today, you can do it as well without waiting for, let's say, the new storage. Okay, I think we're running out of time. Yeah, it's 12:15. So first of all, thank you very much for attending the session, not falling asleep, even if this is the second day and we are almost to the end. And if you want to catch up and if you want to know more, feel free to come to our booth that is exactly next to the food. So if you want even to sit down just to rest and so on, to say hello, we will be more than happy to go and have a chat with you. Thank you.